why AI is getting driven. Okay, so the first one is the 5G connectivity. But if you have a strong backhaul connectivity and connectivity like 9 Gbps of throughput can be get through one cell, you know, 5G can give up to 9 Gbps. So if 9 Gbps of throughput can be done, then you can do lot of real-time analytics on data happening. So assuming that if n number of cars driving on a road and they are generating a data, if you want to take certain congestion-related decisions at a real-time basis, you can do it with AI ML algorithm for part. But connectivity bring those things to you. Second, till now what we have seen is there are connected devices, there are meters are getting smarter. Okay, electrical meters or water meters are getting smarter, but those are still a standard, standstill meter. But look at the car, autonomous car. Look at the connected AGVs, robotics, drone. Now it's not that along with the humans, machines are around us, right? If you go to some of the new campuses, you will see the AGVs moving around us. So all these devices are generating humongous amount of data and they are connected, they are generating data with, so that's another requirement that AI will, because if this data is being generated, how does it will use, how, whether there could be a data which is not in use, there is a data which is very important. So how do you filter the data? What prediction can be done over it? Those AI ML algorithms will bring it. The third part in the whole ecosystem comes up is that you have cloud computing becomes an availability for everyone, and since cloud is available, you can do lot of big data analysis at the cloud side of it, and edge computing which is still not there, it's getting deployed, but you could see especially in a developed world like US, they have started deploying the edge computing. I don't know how much of you know about edge computing, but I can give a very small brief about it. So look at today, if you look at the cloud computing, you have cloud deployment happening at Mumbai, Delhi, at some of the central location of it. Now what is happening, what is changing is for the real time part, let's say if I have cars moving around Nagpur, all the car data cannot go to Mumbai and then you can take a decision behind. No, it will not happen. So you will have to have the edge compute environment which can locally deploy in Nagpur. Maybe in Nagpur sectors can be, whole Nagpur can be divided into 4 or 5 part of it. So that's where edge computing, edge deployment is happening. So you could see next 4 to 5 years, a lot of smaller data centers will be getting deployed. A lot of new companies will come and say that, hey, I am deploying a servers and infrastructure, you can put your software on top of it. So I don't know how much of you know or anyone of you know Amazon Wavelength. Okay, so Amazon has a product which is known as Amazon Wavelength, which is basically edge computing platform where, let's say if Nagpur city wants to have wavelengths deployed, they can bring in this city with they bring their own data centers here and then they can use the edge computing part of it. That's where Amazon Wavelength is there. Go and read it. It's a good platform there. So it's not a cloud, it's an edge computing platform. The fourth one is, we talk about computer vision. We all know that we all do a video conferencing, we do a Zoom calls, we do a team calls, we do we have seen a lot of cameras when I'm driving my car. I cannot drive more than 120 kilometers an hour speed because I know that cameras will catch up my number plate of my car and those things, right? So computer vision technology has changed significantly. Uh, uh, a lot of improvements happen. So go back a little bit of 3 to 4 years back, you could not even detect the number plates from the image of the part of it. But now with the AI with a lot of algorithm running behind, you can detect whether it's a human, whether it's an animal, whether it's a particular person or gender. You can create. So computer vision has, as a technology, image processing computer vision has actually bring a lot of inputs for the AI algorithm to build on top of it. So these are the 4 areas. Actually, if you see AI, I would say these are the basic ingredients for an AI to percolate and build on top of that. So these are the 4. So if someone can think about, one part is developing the algorithm of an AI. These are the building blocks of the. If you are developing an algorithm, let's say if I have to identify and build an algorithm that how closely car can come together and collision can be avoided. So collision detection can be done and collision can be avoided. Now these sensors, connected devices, you need image processing thing, you need cloud data. So these are the building blocks for AI to populate. And then where it is being used, it's being used into the transport industry. We talk about each of them more detail of it. Transport, manufacturing, retail, healthcare, and telecom. These are the few areas. I will not say all of them, but I'll list it on a couple of them so that we can talk about it. Go to the next slide. Now, if you look at the transportation industry, when I say transportation, transportation means a personal vehicle is a transportation. Autonomous vehicles is we all are talking about it's happening. In fact, in US, some of the cities, it's not at a mainstream areas, but in some of the cities, there are autonomous vehicles are already being started. And it is being used for the public transport system kind of thing. So people have started building it. It's not being still not on the mainline part of it because it's not into the area of New York. It's into the area of where low density, low population areas where autonomous vehicles have come from. I don't know. Anyone of you know V2X? What is V2X? So there is a concept known as vehicle to vehicle communication and vehicle to network communication. So what is happening? What will happen? In future is that on your highway you will have a roadside unit. So each vehicle will talk to another vehicle, and then that vehicle will talk to that vehicle, and then there is a roadside unit. It will talk to that. So now let's say if I am driving at a speed of 140 kilometers, and and we can see at maybe half a kilometer ahead there is some speed getting slowed down. All the vehicles speeds will get slowed down. So this can only happen with a V2X kind of building block. For that you need to build a lot of algorithms. So algorithms could be that how sync your car can move. When these are they all are running in an autonomous way or even into semi-autonomous way, it will assist you in driving. So you know, I drive a car BMW. You know, I can park my car without any human intervention, where it will detect all. So it is using a technology which is known as a computer vision. It is using a technology with lot of lidar sensors around it. So similarly, the V2X is a technology where you can actually taking the data from V2X and creating the AI algorithm which is required. I will not talk about much onto the algorithm part of it because that's something which you all have to create of your own based on the problem statement it will come to. But I'll just tell you about what are the use cases AIs are bringing in or helping into it. So in transport, all inside autonomous inside vehicles, there are a lot of AI algorithms are being built up so that you can human don't have to think much. Vehicles will do all thinking for you, and that's where you are creating an AI brain, and then self-learning, machine learning algorithms into it also. So if you look at the new vehicles which are coming up, whole car is a compute. It's an electronics compute. It's a completely electronics compute with all the sensor data being collected and safety being created around it, so that you can drive a car at 200 kilometers per hour speed. Look at the manufacturing is another industry where we do a lot of manufacturing, and then important part for manufacturing is that how do you control your quality. So I'll just give an example. Any one of you are from mechanical industry? You manufacture a car gear, right? While manufacturing car gear, if gears you know uh, some damper of 0.01 mm, then it's being rejected. Now measuring it with a human eye, it's a very very costly affair. But with an AI algorithm, on the real time with an AI algorithm, you can detect an image, you can have n number of cameras around it, you can create a image processing unit on top of it, create an AI algorithm to identify the quality of the product, whether it can be given to go back to the next level, or it needs to rework on it. So that's another area where we have to talk about quality assurance part of it. You you know I'll give a very simple example. When we were working for one of the customers, they said that they want to create a AI algorithm for the inductor motors. So if you look at the I know most of us have done electrical engineering. So inductor motors have a life of 15 years, right? And based on the noise of the inductor motors, you can actually determine how does the wear tear of the coil of the inductor is happening. Now, with those noise and vibrations, you can create an AI algorithm. So what we built in past is that we created a Bluetooth-based sensors onto the inductor motor and collected the data to the edge computing part of it and created an algorithm based on the sound of the motor, based on the vibration. We could determine what is the life and can you have to do predictive maintenance before it gets failed. So those kind of things are coming in there where AI can help in a manufacturing part of it. In a telco, it's a uh, telco will help or 5G will help AI to be built up, but itself for 5G to deploy, you can build lot of AI algorithms on top of that, where we talk about QS, slice management, ORAN. I don't know. In 5G there is something known as ORAN, which is basically distributed RAN environment. So there are a lot of intelligent algorithms needs to build up. So I'll give a very simple and crude example of it. Uh, let's say we are sitting here and we have a tower nearby, right? And in a daytime in your college you have n number of students here. Now, what I can do with an AI algorithm is that I detect what time person are coming, what time they are leaving, what kind of resources do I need in this coverage area of campus, and then I can increase the power of the base station so that plus power plus frequency planning I can increase, and as soon as after 6 o'clock I can reduce those powers and everything. So I can build an AI algorithm or machine learning algorithm where I can predict what time what will happen, and then I should with an AI system I can also say okay, this day there is some event happening, automatically those resources are getting aligned to it. So those kind of algorithms can be built on using AI inside telecom itself to be used. Healthcare, we all know that medical science, doctors are now more becoming engineering and doctors are merging together. So a lot of solutions are being built up. In fact, we are working with a company known as Colleges, which is basically they manufacture a lot of health equipment, and where we are helping them in building the AI algorithm for the heart surgery part of it, whether based on the lot of video data being collected. So again, image processing based things are happening. People are saying that if you scan your body at a multiple iterations, and then you can determine what I'm not a doctor, so I will not talk about much about it, but if you look at medical science itself with the AI ML plus the technology building together, there is huge focus opportunities to there also. Now I'll talk about more you know uh, telecom and 5G merging together, or AI and 5G merging together, and how do I see or we see as both going hand to hand. And if you look at overall telecom industry, and why I'm talking telecom, because as an AMANTYA we are a primary telco plus AIML company, and that's why I wanted to give this perspective of it. Definitely there are other aspects of AI towards the healthcare or other industry, but I'll touch base about telecom and automotive. These two sectors I'll touch base on more. So if you look at 5G has given us 20 times more bandwidth, more processing power, and that will help building solutions around us, connectivity solutions, algorithms. So take an example. Today you have traffic lights, right? If you look at today's traffic lights, it's almost static. On one side of it, it will 60 seconds, 60 seconds, or 30 seconds, 90 seconds based on it. It's a manually being driven. Can you predict? Can you make predictions around it? Can you do, so you need a lot of sensors, you need a data, and then you need a prediction algorithm running it. And you can say that, okay, during the daytime, during the day hour, you can actually turn on or change the timing or at least the delay of each traffic light. So those kind of algorithms can be built on top of that. So inside telecom, definitely. Have you guys know what additional 5G bring over 4G apart from speed? Or should I talk about it? So there is a concept known as network slicing in 5G. So let's say in your